This is for Year 12 methods that comes out of Set 1C, and it's finding the implied domains for the following rules, and there are a couple of parts of question 8. Do you need to draw these graphs? No, you don't need to know how they're drawn. The implied domains that we have problems with are these are the three situations that we can't do in mathematics. So these questions are being created because I have a denominator, therefore x minus 3 cannot equal 0 because that would have a division by 0. So x cannot equal 3, therefore my implied domain is x is an element of all real numbers except for 3. In question 2, or part D, I've got a square root and I've got a square root. X has to be able to fit into both of these. So x minus 4 has to be greater than or equal to 0. So x has to be greater than or equal to 4. And, so intersect, 11 minus x has to be greater than or equal to 0, which means minus x greater than or equal to minus 11, or x less than or equal to 11. So x has to be bigger than 4, but equal to or less than 11. Therefore, the only values of x are those in the middle. Therefore, in this particular case, my domain will be 4 till 11. In the third example, I've got a denominator, and because I've got a denominator, x cannot equal negative 1. At this point, I'm not interested in what the top is, because anything of value of x can go in there, but x can't equal negative 1, because my only concern are denominators, under square roots, or inside logarithms. Therefore, x is an element of all real numbers except for negative 1. In G, I don't care about the numerator, there isn't even an x there, but there's two occasions where I have problems. When x equals negative 1, and also when x equals 2, I have my denominator is 0. Therefore, x can be all real numbers except for negative 1 or 2. And in example H, I have this fraction, but it's all under a square root. So I know straight away that x cannot equal negative 2 because that's in the denominator of the fraction. But I also have the situation where x minus 1 over x plus 2 has to be bigger than or equal to 0. It can be 0 because I can take the square root of 0. Now, what's the algebra that I can do? If I pick my denominator up and move it to the other side and multiply it by 0, I've got a problem because I don't know if x plus 2 is positive or if it is negative. So some values of x it is positive, therefore I wouldn't have to change the sign around, but other values of x it's negative, and I would have to turn the inequality sign around. This is a problem when you're multiplying and dividing by my variable, that when you have inequality signs, for values of x like negative 3, negative 4, negative 5, this denominator is negative. But for values of x like 1, 2, 3, this denominator is positive. So I'd like to explore what is this. I'll do a quick little division. So x minus 1, x plus 2, x goes into x once, so x plus 2, and I'm minusing the second, I have negative 3 as a remainder. So I've really got the square root of 1 minus 3 over x plus 2. And this here is a hyperbola. Hyperbola which has an asymptote at -2. And that makes sense because I've already excluded -2. It's a negative. Oh, sorry, it has an asymptote at 1. And it's a negative, so therefore it's going to look like this and that. Now, what can't it be? It can't be 0 and it can't be negative. So they're the values of x that it can't be. But these values of x and these values of x are all fine because the hyperbola is positive, and I can take the square root of a positive number. So what is my x-intercept? My x-intercept is when y equals 0. So I've got x minus 1 over x plus 2 equals 0. That's when x equals 1. So that's my x-intercept of 1. So what's my domain? My domain is -infinity to -2 union 1 to infinity. So I started the video by saying no, you don't need to draw them. I didn't need to draw the square root of x minus 1 over x plus 2, but I did have to explore what x minus 1 over x plus 2 was. Hope that helps.